All right, guys, thank you for coming. And today is mainly just the time for you. So if you got any question, you can just raise them up on the chat or speak up. And if you haven't really tried the example questions on the e-class, you definitely want to try. That might help a bit, on the review. But you definitely need to make sure everything that's specified as coverage, you really need to study them. The example questions are not really meant to be complete, right? So you might get more questions, or the question themselves might be harder. At the moment, I haven't really put the final questions together, so I'm not exactly sure how many questions you might have, but I know that you got 30 minutes, right? Anyway, all right, guys, it's your time. Go ahead. If you got any question, chat or speak up, either way. Yeah, I'll give you guys some time to think about if you're still thinking what question you might have.
Hi, Professor.
Yes, please.
Um, so can we do examples 3, 4, and 5? On It's from lecture 2, so pages 34 to
Okay, give me a moment.
36.
Are you referring to the slides or the iPad notes?
The lecture slides.
Lecture slide. Okay. The asymptotic analysis, right?
Yes,
Okay. Which slide again? 24?
34 to 35. Oh,
Okay.
sorry. Let me double check.
Yeah.
34 to 36.
Yeah. 34 to 36. You mean to
Yes.
approximate the running time?
I would like if we can find the exact
Or the
running time
exact?
instead of
Okay, sure.
approximate.
Um, so how about this? I think for 34, I would suggest, because 34 is just the same as your example questions. So for that one there, we can still do it if you guys really find the need, because let me show you guys first. For 34 here, just in case you cannot really find it. After you submit your attempt on the example test, you will see that this discussion video over here, you want to go there, and then on this, starting from this particular timing, that one discuss exactly this example here about how many primitive operations there will be. That complete discussion take about 15 to 20 minutes. So Maisha, have you checked it out already? Or that's something you
Yeah,
don't
I
find
did.
clear?
I think I need help mostly on the example 5
Example five.
mostly
Sure.
because yes.
You mean when you say, oh, example, sure, no problem. So how about this? If you guys have any trouble about counting, so we're in the lecture, we spoke about how you can approximate the running time for this example over here. But if you want to know how to calculate the precise number of primitive operations, it's actually in this particular link and also timestamp I just suggested. So you guys can still find a very thorough discussion on that. So for now, I'm gonna skip this, right? Just for now. And so Maisha, how about this? Do you want to do this one or number 5 first?
Um we'll be doing both, right?
Yeah, we can do both. Yeah, that's not a
Do we
problem.
have
Okay. So you're
all
asking
right,
not
I
to really
appreciate that.
approximate, but to calculate precisely how many primitive operation. Is that
Yes.
correct? Okay. Why don't we do it?
Yes.
Let's do it. Give me a moment. Let me set it up. Yeah, I'll just get this fragment over here and then we'll take a look. Okay. Yeah, let me set up my iPad very quickly and then we will switch. Okay, let's give it a try. Okay, let me switch. Okay, let me move my iPad a little bit. All right. Okay, let's now take a look. So guys, like in the classroom, if there's anything you think that's not clear, you can just I'll try to keep my eye on the chat as well periodically, but just shout out, if you got any question. All right. So the question is, we want to calculate the precise number of primitive operation. Okay. So we want to count the number of primitive operation. Let me write it down here. So we want to count the number of primitive operations. All right. Let's now take a quick look on the overall structure to see the example here. Line number 2, quite straightforward. So this for loop, we should really talk about it, but that one doesn't seem to be too difficult. And Maisha, actually, this one here, that's kind of the find max that we spoke about before, right? That's a find max. So this one is not too bad. And also this one here. And this is kind of like a nested loop. I believe that one there, that one we can also do precisely. Anyway, so we have to deal with mainly this loop here and also this loop here to be precise. So let's see. Let's do line by line. Okay, line number 2. How many primitive operations do we have? Well, we got array indexing, and also we got variable assignments. All right, so here we definitely got 2. Right, that one's straightforward. And what about the for loop over here? Okay. Luckily, this for loop over here is not nested, so it should be rather easy to really handle. You just have to remember 2 critical questions, right? If you remember the find max problem that we solved together in class, you have to know, number 1, how many times you're going to execute the body of the loop. And number 2, how many times you're going to evaluate the state condition over here, right? So you want to understand these. Let's now take a quick look. Okay. So number 1, number of times the state condition, which is I less than n. I less than n is evaluated. Number 2, number of times the body of loop is executed. All right, so these are the 2 critical questions. All right. Why don't you guys tell me, first of all, question number 1, how many times do we need to evaluate this I less than n, including both true and false? Okay, Farah said n. Okay, I think that's pretty promising, right? So think about, we're gonna start with 1, and then all the way to starting from 1 all the way to n minus 1. That'll be all the true value. And then the final one will be when I is equal to n. And that will evaluate to false. And Maisha, are you okay so far? So that should be n.
Yeah, so the for loop statement is true for n minus 1 times, and then added
Yes. Yeah, let me just write it
plus
down.
1 because it'll be false. It'll be false for 1.
Yeah, for this
So
one,
n
let's write it
minus
down.
1 plus 1 is 1.
Mhm.
Sorry. N minus 1 plus 1 is n.
Yeah, that's correct. So from 1 until n minus 1, these will give you the true value. And finally, when you get to n, so this will be the final one. That's going to give you false, right? So overall, we got from 1 until n inclusively. So n times. All right, and then exactly n minus 1 will be the number of times you will evaluate to true. That means the number of times we're going to execute the body of the loop. So this will be n minus 1. All right, and then what about the number of primitive operation in the body of the loop, right? Let's take a look. Array indexing, assignments, also relational operation, another array indexing. So overall, we got 1, 2, 3, 4, right? 4. So how do we add it up? You want to think about it's something like this. So I equals 1, that's the initialization, will be executed only 1 time. And then this comparison here itself is just 1 primitive operation. But how many times it's going to be evaluated is going to be n. All right. Plus, think about this I++, right? I++ over here is equivalent to I assigned to I plus 1. Itself has 1 and 2 primitive operation. Multiply by how many times we're going to make a progress. So that will correspond to how many iterations we have. So that'll be 2 times n minus 1. All right, and then finally plus 1, 2, 3, 4. 4 times n minus 1, right? Let me just make some annotation just for your benefits later. Think about this is I is assigned to 1. The n over here is about I less than n, will be evaluated this many time. And this one over here, the 2 here is the I++. And the 4 over here is line number 4. All right, let's try to simplify this quickly. Okay, let's see this. Okay, so we got n plus 2n plus 4n, right? So 7n. And then 1 minus 2 minus 1 minus 1 minus 4 minus 5. Actually, Maisha, if not surprised, I think that this is actually what we did, right, in the class, but I'm just redoing it again, just to double check that you actually got it. Are we okay so far for this? Okay, I presume silence means you guys are fine. And then, what about this one here? This one here, just a variable assignment. So 1, all right? So far we have done 2 here, 7n minus 5 here, 1 here, right? I'll get to the nested loop in a moment, but let's now do the final one here. So this one here is also 1. All right, so that one there is also 1. Ultimately, we have to add up this, this, and also whatever this is. That's something we got to do. So let's now try to calculate how many iterations, how many times, how many primitive operations there will be. All right. So now let's box this over here. Okay, let's now take a look. Right, we have to really look at a pattern, right? Every time you actually got nested loop, almost like a no-brainer. You should really observe the patterns for the loop counter, right? We've done 2 examples or 2 or 3 examples already in the class, right? So this one should be no surprise. So when j is equal to 0, right? Let's think about what's going to be the possible values for j. When j is equal to 0 and until j equals to n minus 1, right? So let me just write a little bit better. A moment. So j value is going to be from 0, 1, 2, all the way to n minus 1. And of course, this one special value over here, that's the final one, right? So when j is equal to n, let me just make an explicit note because we should also count it. That's also important. So this will be when j minus n evaluate to false. So this one here should be counted alone, right? Whereas these values are when j less than n will evaluate to true. In that case, we have to see how many iterations there are, right? Okay. When we approximate, you don't really have to be this careful, but when we calculate precisely, you have to be. All right. And let's now try to see. What about the inner loop? The inner loop, let me use how about this color here? Okay, for the inner loop over here, it's going to be k will be from 0 all the way to n minus 1. Similar pattern, right? So for k, it's going to be from 0, 1, 2, all the way to n minus 1, right? But notice that the n minus 1 over here is the last value where we can make k less than n true. But there will still be a value where k is incremented to n. So that will make it false. We also need to consider that separately. Okay. So think about this value over here is when k less than n would evaluate to false. Right? I hope you guys are okay, right? So far, right? You can see I'm now doing something a little bit deeper than just approximating, right? We need to be very careful in counting. But in case you think I missed anything, feel free to raise it up so we can take a look. All right. So let's now complete a pattern, and then I will calculate very carefully. All right. What about when j is equal to 1, right? K is always from 0 to n minus 1. It's always the same pattern, right? So that'll be from 0, 1, 2, all the way to n minus 1. and also 0, 1, 2, all the way to n minus 1, right? And when j is equal to n minus 1, also 0, 1, 2, all the way to n minus 1, right? You can see what about when j is equal to n? That we don't need to fill out anything anymore, because when j is equal to n, the outer loop is going to exit. In that case, we have no inner loop execution anymore. All right. And of course, you have to make sure you calculate also the number of times when j is equal to n. So these are all the values that will make sure the inner loop also exit. Okay. Okay, you can put it here. All right. And let's now count very carefully. Oh, before that, let me do one more. Okay. Let's say here. What about line number 9? How many primitive operations do we have over here? One here, one here, and also one over here. And think about this one here. I can expand it a little bit. Sum equals sum plus, right? Assignment here, and also plus over here, right? So in total, how many? 1, 2, 3, 4, and 5. For that, body of the inner loop is going to be 5. Right, so now we have got everything we need. All right, so I can see some correct answer from the chat as well. Very good, right? Right, so far there should be no surprise, right? Let's now be very careful, okay? You can, let me highlight the ones that will only be executed only once. Let me highlight them first. You can see this one will be executed only once. This will be executed only once as well, right? Let's count them first. So it's going to be basically, let's say 2, okay? This one here is j equals 0 and also k equals 0, right? And then plus. How many times are we going to evaluate j less than n? Right, so that one there, this one here, yeah, depends on how many iterations we have, right? This one here is going to be evaluated this many times, right, until it gets to n. So that will be from 0 all the way to n. That will be n plus 1. Okay. So this will be n plus 1. So n plus 1 over here is the check j less than n. All right. And then the next one, how many times are we going to evaluate this one over here? All right. This one is a little bit tricky. Okay. I would say this might be the trickiest one. Might be. All right. Arguably. So do I have any other? Okay. How about this? All right, guys. How about this? Let me pause for 30 seconds over here. Think about what's going to be the number of times the k less than n that is going to be evaluated. How do we see that? Okay, I see some answer over here. But before I work it out together with you, you want to think about it precisely. How many times? Okay. If you got some answer, feel free to share on the chat. So far, we only got one answer in the chat. So the question is, how many times precisely this condition over here is going to be evaluated? How many times precisely?
Sorry, I have a question.
Yes, I have a question. Yes, go ahead.
In the first for loop, it's n times, but in this one, it's n plus 1. Why is that? I think I missed that.
Which one are you talking about? Sorry, which one?
Sorry, in the for loop you highlighted in green, it evaluates n times, but the one evaluate the first, like the outer for loop in purple, evaluates n plus 1 times.
Look at the initial value here. You can see this one starts with 1. This one starts with 0.
Okay.
That makes a difference.
Okay.
I guess that's what you're asking, right? Maybe.
Yeah, that's
Yeah,
why.
okay, very good. But Peter, be careful because when we calculate the precise number of primitive operation, you got to be very precise. Good. All right. All right, guys. Hopefully you got some time to think about this, right? I can now tell you, right? Of course, you got to work it out during the test yourself. Right. So think about for every value of j, okay, thinking this way. For each value of j, making j less than n true. This k less than n condition is evaluated. Let me write it down first, and then I'll go over that with you. It's evaluated. You can see from 0 all the way to n, right? That's n plus 1. Okay, so what do I mean? For each value of j, which makes j less than n true, that means we only get to evaluate k less than n when we are actually in the iteration body, in the outer loop over here. So we shouldn't really count this one here, right? So that's why this part over here is going to be 0 all the way to n minus 1. So that'll be n. So just this part over here will be n. And then we also got n plus 1. The n plus 1 is suggesting about whenever you get to evaluate k less than n, it's going to be from 0 all the way to n. So that's going to be n plus 1. All right. So overall, it's going to be n times n plus 1. So the answer on the chat was correct. Of course, if you didn't know how to work it out, hopefully now it's clear to you. This will be about k less than n. All right. Let's now continue. All right. So now we have worked out exactly the initialization and also the two state conditions. Let's now work out this one and this one. And these two somehow correspond to the iterations. All right. Let's now be careful. Okay. Plus. What about j plus plus? J plus plus itself, we know that it has, it's j equals j plus 1. So there are two primitive operation, right? So it's going to be 2 times. And how many times are we going to do j plus plus? It should really correspond to number of iterations for the outer loop, which will be n. So this one here is about the j plus plus. And plus, how about k plus plus, right? K plus plus is about how many times we're going to update the inner loop, right? You can think about we need to update the inner loop whenever we actually got some valid value for k over here. But we shouldn't really count when k is equal to n, because that is when we exit from the loop. So that one should be excluded, all right? So let me write it down. So k plus plus itself is actually just 2 primitive operation, but we now need to worry about how many times do we actually execute k plus plus. Every time for any value of k that's going to make k less than n true, we're going to execute it once. So if you try to count exactly this square over here, how many do we have over here? All right, so here, let's 2 times. So this itself is 2 times. And this one here, this part over here is from 0 to n minus 1 is n. And this part over here from 0 to n minus 1 is also n. So we got n squared, right? All right, so this part over here is about the k plus plus. All right, I think the only part that's missing is this part over here. But this one here should really correspond to how many iterations you have for the inner loop, right? That should really correspond to just n squared again, because you only execute the body of the inner loop when you actually got a valid value of k, which will make k less than n true, all right? And we counted before, this part over here has 5 primitive operations. So we're going to get 5 times n squared. So you can see quite a bit of details when you actually need to count precisely, but I think it's a very good exercise for you to be very precise and very cautious about how things are going to be executed at runtime. All right, so this one over here will be line number 9. Okay, I believe we have to also include the one over here, right? Line number 10. All right, I'm pretty sure you guys can actually add these up together, and whatever the answer is, it will be the answer. Okay. I'll let you guys do that final bit of math. But apart from this, do you guys have any question about the way we derive it? Now will be the time to ask before I move on to the next example. Maisha, that was your question. Do you have any questions so far?
So for line 7, right?
Line 7. Okay, let me take a
When
look.
I got
Yeah.
so I know that the for loop condition stays true for n times,
Yes.
and then we add 1 to it because so it'll be n plus 1, right? Like how you said. And then for line 8, it's basically you multiply the number times the outer loop is
Yeah,
true
so Maisha, you may
times
want to
the
think in
number
this
of
way.
times.
So I think that's why, visualizing how the loop counter actually change will be the most effective way to understand. Let me maybe repeat that part. That might help. Think about just for the outer loop counter j here alone. We go from 0 all the way to n minus 1. All these values are going to make j less than n true. So that's why this part over here tells you these are the actual iterations. And when you get to the final value n, that one wouldn't incur any iteration because n less than n is going to make it false. So this one here alone tells you now it's time to exit from the entire nested loop. All right. And then for every value of j, we are going to execute this part over here. And how many iterations do we have? It depends on the value of k. So k from 0 all the way to n minus 1. However, similar as before, when you execute this in the loop, when it has the value of k from 0 to n minus 1, it's going to make this state condition true. But it will be a final time when k is incremented from n minus 1 to n, and that one is going to make this false. But that one there would not incur any further in the loop iteration. In that case, when it gets to n, this part over here is going to be false. And then you don't really execute this for another time. And then you go back to the beginning of the outer loop. So you really want to get that big picture clear in order to count. All right, so I got a question here. Can I explain how we got n times n plus 1? Okay. Okay, k less than n. Okay, sure. Let me repeat again. So k less than n over here, think about it. It's actually going to be, okay, thinking this way. Yeah, this one might be the trickiest part. Let me try to draw a little bit. So k less than n over here is really corresponding to this part here. Try to take a look here. So there are two things you want to really keep in mind, okay? You will only execute this statements if the outer loop is not exited, right? Because if the outer loop is already exited, in that case, you don't even get a chance to go to the inner loop. That's inside number 1, right? So let me put a very quick notes. I'll put star over here. Oh, let me put a star. Okay, so I'll put it here. K less than n only executed before the outer loop exits, which is when j is equal to n. So that's why we're only calculating from j equal to 0 all the way to j equals n minus 1. So we only got this many times from 0 to n minus 1. We only got n times. that we actually have to evaluate this header of the loop. But when you actually execute this in the loop over here, you also have to follow the same logic. You'll go from 0 all the way to n minus 1, 0 all the way to n minus 1 to make sure you got a true value for this k less than n. And then for the final time will be when k less than n becomes false. That is the time when you actually exit from the inner for loop and go back to the outer for loop. So you really want to think about what's really happening when you run the code at runtime, right? So that's why you got n here corresponds to how many times the outer loop is going to incur the inner loop. And also n plus 1 over here is about when you execute the inner loop over here, it's going to be from k will be from 0 all the way to n over here. And then you add it up together. All right, so that's a response to the question from the chat. I hope that kind of helps. If no, feel free to say it's not clear. Okay, very good. So I'm glad actually this question was asked. I think that this one is not as trivial as we might think, right? So it does require very careful thinking. So Maisha, do you have any other follow-up? Yeah.
Yeah, can you quickly explain how you got number 2? That's the purple number, the purple.
This one here?
The number that's purple? Yeah, that one.
Okay,
yes.
this one's straightforward. This one here is just about initializing the loop counter over here. Oh,
okay.
Oh, you know what, Maisha, you know what? I'm glad you asked over here. Okay, very good. So this one, okay, this one is not exactly right. Now I got it. No, you may, no, I might got why you have doubts. Guys, I made a mistake. I'm glad Maisha pointed out to me. Let's be careful here. So for j equals 0 over here, it should be 1. Got it. Okay, now I see. I'm glad you actually pointed out to me. So guys, only this part need to be fixed. J equals 0 is only initialized to be once, only this time. But I can see how many times k will be initialized. It should be exactly this one here, right? So that's what's missing. Okay. So what I'm going to do is I'm going to say, let me just write down properly. I'm glad. So this one here will be plus, let me write it down first. And this will be k equals 0. So why is this the case? One here is about how many times we're going to initialize j to be 0, which is exactly this one time. And how many times will we actually initialize k to be 0 every time the inner loop is incurred by the outer loop? In that way, you can see how many times we initialize k to be 0. That should be from here all the way to here, from 0 to n minus 1, so n times, right? So that's something I didn't really do properly, but now I think that's complete. So Maisha, maybe that was your doubt, right? I guess.
Yeah.
Okay.
Also, for the first n plus 1, shouldn't you add another 1 to it because of that less than symbol in the first, in the
So this one here is about how many times you will execute this, right? So think about how many values are going to make it true. That will be from 0 all the way to n minus 1. That'll make it true.
Yeah.
So this will be n. And then the final value is
that'll be n and then plus 1.
Yeah, so n plus 1.
Yeah.
Yes, you should be n plus 1.
Should we add another 1 to it? Because do we have to consider that symbol, the less than symbol, as an operation?
No. I see what you mean. Think about every time we execute this this expression over here, the expression itself contains just one primitive operation. And how many times do we execute it, right? So the first n times we execute it, you will incur n times 1. And the final time is going to incur just 1 time. So you add it up together, you get n plus 1. You don't plus another 1.
So it's just n plus 1.
N plus 1, yeah. Think about the n here is the first n times where this expression evaluated to true. The 1 here is the final time when j has been incremented to n. In that case, n less than n will be false, right? That's exactly n plus 1. Yes. All right, guys. Any more follow-up question you would like to ask before I move on? All right. All right, let me move on over here. And then, so Maisha, you said you also want to do number 5 over here, right? This one here?
Yep.
Okay, this one will
Yes.
be kind of similar. Okay, but since you ask, so I can definitely do it, no problem. Okay, let's do this one here. Give me a moment. I'll set it up, and then we'll do this one too. The idea will be very similar. You will just have to observe the pattern and count very carefully. But let me set it up. Okay. All right, this one here. Count the number of primitive operations. All right, let's now take a look. All right, this one here. I think that there will be many things that are similar to the previous example. So if something I can speed up a bit, I will speed up a bit so I can save some time in case you guys got other questions. But I'll still make sure it's covered properly. So this one here is just 1. All right. And obviously, this one here is also 1. And then what about this part here? The body of the loop, the body of the inner loop, to be more precise. That one there is going to be, so this one would be as if sum equals sum plus, right? So you basically got assignments, you got arithmetic, and also you got array indexing. So that one there should just be 1, 2, 3. All right, that one would be 3. All right, so far so good. So what we need to work out is the loop header. So let me say the outer loop over here, and also the inner loop. Let's now try to do the loop pattern first, and then from there we can work out the various things. Okay, let's now look at the loop pattern. So for the outer loop, we got I value will be from 0, 1, 2, all the way to n minus 1. N minus 1 will be the last value that's going to make this one true. But don't forget, we also need to include n. So that'll be the value that will make it false, right? This will be the value when I less than n, evaluate to false, okay? And let's now try to do the inner loop, okay? When I is equal to 0, j is going to start with I equals 0. Oh, sorry, j always start with the value of I, all right? So that's going to be from 0, 1, 2, all the way to n minus 1. I'll put a parenthesis so you see there's one integral part. And then the final value is going to do to make it false will be n. All right. What about the next time? When I is equal to 1, j will be from 1 all the way to n minus 1. So these are the true value, right? And then the final one will be n, which will make it false. 1, 2, all the way to n minus 1, and then n. Okay, this will be 2 all the way to n minus 1, and then n. All right. And it goes on. For the very last iteration, it's going to be n minus 1 and also n. Right? You can see we're doing something very similar as the previous example, but let's complete it, right? Just make sure you're okay. All right, if we do this one here, just make a note over here. So these are the values which will make j less than n false. Okay, so these are, all right, very important to note. All right, so let's now try to count very carefully, okay? Number 1, how many times are we going to execute I equals 0? Only one time, right? You can see it's only initialized once. So that will be just 1. So this one is when I is initialized to be 0. Okay, plus. What about when j is equal to I? How many times do we really do we execute this initialization? How many times? Anyone? Similar to what we just discussed.
Is
Maisha,
it
you want to
n
try?
plus 1?
Say that again.
Is it n plus 1?
How did you figure?
Is it, sorry?
How did you figure? How did you figure it's n plus 1?
Because it's the I will run until n minus 1, and then it'll run one more time. So n minus 1 plus 1.
Remember,
Oh
we're
no,
only
wait.
talking about this one here, right? Remember, you can only
Yeah.
get to the inner loop if there's no exit from the outer loop. But when you also count this one time, it's not right? Because this
Yeah.
is when we exit from the outer loop, so there'll be no more iteration for the inner loop. Maisha, you're getting it? Okay, I see
Yeah,
another
so
answer there, n minus 1. Okay, so how about this? This one here is going to be, think about j equals I. 1, 2, 3, all the way to n minus 1. How many times? 0, 1, 2, all the way to n minus 1. It should be n, right? Yes, I can see some
n.
nice formula
Yes.
over there, right? Okay. So these are the values which can show to you that how many times we initialize the inner loop counter, right? So now you can see how valuable it is to really make sure you enumerate exactly the loop counter, so you can see really what's going on. That can also help you better understand exactly nested for loop actually work. All right, so this will be, let me just put it down, will be just n. So this is about j equals I. All right, that's good. And let's now move on. What about this one here? I less than n, right? Plus I less than n. Well, we got this many times that will evaluate to true, and this many times that will evaluate to false, right? So that will be exactly from 0 all the way to n, which will be n plus 1, right? N plus 1. So that will be I less than n, all right? What about j less than n? This one here, all right? This one here, again, this will be the trickier one, like a previous example, right? What should this be? How many times? And for those of you who are still lost about how to calculate this one is the trickiest one, I can tell you, okay? Think about for each of the, this one is only executed when you are in this range for I, okay? How about this? When I is between 0 and n minus 1, right? So we're talking about the width over here, right? And then how many, for each one of them, let's say when I is equal to 0, how many times do we have to evaluate j less than n, right? That one will be 0 all the way to n. That'll be n plus 1. Agree? Okay. Okay. When I is between 0 and n minus 1, j is evaluated. Okay, how about this? J less than n is evaluated between, and then I'll try to count together with you, between I and n. Because you start with I, and then you will end up with, when j is equal to n, it's going to make this less than false, right? But so this part over here is about a little bit more abstract pattern. You can definitely take a look. I think that's correct. But let's now try to count. When I is equal to 0, we have to evaluate this from 0 all the way to n. That'll be n plus 1, right? N plus 1. Plus, what about when I is equal to 1? 1 all the way to n. When I is equal to 2, 2 to n. So that should be n minus 1, right? all the way to when we get to the final one over here. So it will be 1 and 2. So 2. Right? So this is our friend of the arithmetic sequence. And how do we calculate this? Right? The first term will be n plus 1. The last term will be plus 2. Multiply by how many terms there are. But you can easily see, because we go from I equal to 0 all the way to n minus 1. So we got n terms divided by 2. All right. This part here, I'm just going to write it down over here, right? That's how we work out. So this will be n plus 1 plus 2 multiplied by n divided by 2. And guys, are you okay with this? This apparently is a little bit more difficult than how we counted for this one here, because it's a square, it's a rectangle, as opposed to triangle. Triangle definitely takes a little bit more brain power to actually get it right, right? All right, so this part over here is about how many times we will actually evaluate j less than n. All right, I'll pause a moment. The rest are actually much more straightforward. But are you guys okay so far? Any part you want me to repeat? I can wait you guys for maybe a bit, just in case you want to organize. Okay, I'll definitely release the recording, don't worry, but you guys can ask me first. Yes, I heard some question. Yes.
I was just wondering where the you have n plus 1 plus 2. I forgot where the plus 2 came from.
Oh, the plus 2? You mean over here? Yes. Yeah. You can think about, okay, so this part over here is the n plus 1 over here, all the way to this part here is about when you try to get to the final value for I. In that case, j will be initialized to be n minus 1, which will make this evaluation here true. And then j will be incremented by j plus plus to n. That's also going to be evaluated to false. So that's when we exit from the loop. Right? So that's the 2. Make sense to you? Maybe?
Yeah, thank you.
Okay, very good. So guys, actually, I like this example here. It's kind of different from what we calculated in class, which is good, right? We are applying the same principle as we did in class, right? All right, so let's now move on. So what we got left is, let's say I plus plus over here, right? Again, it's I equals I plus 1, and that one there apparently got 2 for each one of them, right? I'll put 2 here just for now. And how many times do we execute I plus plus? It corresponds to how many iterations we have for I. So that should be from 0 all the way to n minus 1. It doesn't include this one, right? It does not. So it will be 0 to n minus 1 is n. So let me write it down. Plus, so this one here is going to be n times 2. All right, so this guy here is about I plus plus. And then the next one, what about j plus plus, right? You can think about j plus plus is part of the iteration, right? So you can see when I is equal to 0, we have to execute j plus plus this many times. When I is equal to 1, we have to execute j plus plus this many times. All right. So that one is very similar to this, but a little bit different. Okay, so what I will do is, for the j plus plus, let me just try to work out together with you for j plus plus over here. Okay. How many times? First of all, each time is going to take 2 primitive operations. How many times? Right? It's going to be, for the first time, it's going to be from 0 all the way to n minus 1, which will be n. N plus, and then for I is equal to 1, how many times do we execute j plus plus? From equals 1 all the way to n minus 1, which will be n minus 1. Plus all the way to the final iteration. Here, this will be 1, right? So what you really want to understand is why this series over here is about n and 1. but here is n plus 1 and 2, right? It's like a 1 more for each term. It's simply because when we spoke about this condition over here, it will be evaluated not just for the true value, also 1 plus 1. The plus 1 is about a false value, right? Just remember that when you studied this example here. Right, this one seems to be easier to evaluate. So it's going to be beginning term plus the n term multiplied by, how many terms do we have? From 1 to n terms, divided by 2. All right. And this one here is very valuable because we can also use it a little bit later. Let me just highlight it, okay, over here. So what we'll do is we're going to write plus, okay, let me see, give me a moment. So that would be the j plus plus. So that would be n plus 1 multiplied by n divided by 2 multiplied by 2. Because j plus plus itself each time is going to take 2 primitive operations, right? So this part over here is the j plus plus. All right. And we got, next one will be this guy here. And this guy here actually very good because we already know how many iterations we're going to have, right? And each time we execute this plus equal assignment here is going to take 3 as we calculated before, right? So that one there is going to be, let's say, plus, and then that one there will just be the same number of iteration here. So n plus 1 multiplied by n, right? You can see I'm just using, okay, let me just finish that first. Multiply by 3. So this guy here is about line number 5. Okay, finally, don't forget, we also need to add number 6, right? That one alone is just 1, right? After that, you're going to get some value over here. I'll let you do the final simplification. I'm pretty sure you can do it. Okay, so that'll be the final answer over here. Right, I think this example here is very nice. You really have to understand why we actually got 2 arithmetic sequences over here. The first one over here, that's a little bit larger. That one there is about how many times we are going to evaluate j less than n, because we also need to consider the false value. So that's why for each one of them, we're going to add 1 each term. As opposed to, if we just talk about j plus plus, it will be only executed when this value over here is actually true. So that's why we only consider this one over here. So it's a little bit different. All right, Maisha, question. You okay, Maisha?
Yeah. I think someone else can ask a question first.
That's okay. I'll let you follow up, and then I can stay a little bit longer just in case we got other questions. But I want to make sure this is your question, right? If there's any part you think I should repeat again, I can do that before I leave this example alone. All right, I presume
Yeah,
you're
just
okay,
give me a
right?
sec. I'm looking through my notes.
Uh-huh. How about this example specifically? Any follow-up question you guys want to ask before I leave it? I can take maybe a few more questions.
Professor, I'm
Yeah, go
still a
ahead,
bit
please.
confused on how we got +2 on j less than n. Just the +2 part, I'm confused.
Oh, so sorry, your question was about how to calculate this?
No, so like you wrote for j less than n, it's n plus 1 plus 2, and then times n.
Yes.
Like I'm still confused on how we get +2 for that part.
Oh, I see. If you look at the arithmetic sequence over here, according to the formula, you have to sum up the beginning term and the final term. Beginning term and the final term, multiplied by the number of turns, and then divided by 2. That's just a formula. Kind of follow, maybe? Let's say, for example, let's say if I give you an arithmetic sequence, let's say we got, let's say 24 plus 21 plus, so it's decrementing, right, by 3. And then 18 plus 15 plus 12, let's say, all right? What will be the answer? It would be the beginning term plus the final term. 24 plus 12 multiplied by, how many terms do we have? 1, 2, 3, 4, 5. divided by 2, right? That's just using the formula. So always include the beginning term, the final term. Oh, sorry. And also the number of terms over here, which is 5 divided by 2. That's what you do.
Okay.
Yeah, so actually this formula is very important. So I think for your written test number 1, of course, this is the only summation formula you will need to know. Once we get to a little bit later, when we do other example, you also need to know about calculating a sum of the geometrical sequence, but it's not for written test 1. So I just give you guys a look ahead. All right, guys, I know it's approaching to 5, but I'm more than happy to stay maybe 10 or 15 minutes longer. So, Ferrets, go ahead if you have any question.
Hello.
Yes.
I
Hi.
have a question about an example we did on Monday. It was the inserting into an array example.
Yes, of course. What about it, Ferrets?
So on line 3 of the example, the worst case scenario was when I is equal to n.
Yeah, so Ferrets, bear with me. Let me just go to that
Yeah.
particular page and then we'll talk about it. Yeah.
No problem. Should be the one we did on Monday at the end of
Absolutely.
Monday.
Absolutely. Yeah. Oh, not here. Should be here. There we go.
Yeah, this one.
Yeah, Ferrets, which line?
Line 3, the green one, the worst
Yeah.
case scenario is when I is equal to n, right?
Yes.
And then on line 5, the worst case scenario was when I is equal to 0.
Yeah.
And we were able to consider both scenarios because the loops are separate. But what if they were like maybe nested and I had to be the same for each for both of them?
I see what you mean. So Ferrets, okay, so 2 things over here. I think if the code goes like this, like a green and blue, they are really not nested. In that case, all you need to consider will be consider each one of them in isolation. You don't really have to worry about. Actually, in fact, when you look into a little bit more into how this method may be executed, the worst case for I here and the worst case for I over here cannot occur simultaneously. Because if, let's say here, if you got, this is what you have to insert over here in index 1. Okay, you can see my mouse cursor over here. If you got more work to do before the insertion to copy whatever that's before the original index 1, right? The more work you have to do before gin, the less work you have to do after gin. The worst case cannot happen at the same time, right? You can think about gin is like a middle pivot, right? The pivot move. If the pivot moves a little bit to the right over here, then let's say we want to insert an index 2. In that case, you got more work to be done on this side over here to copy, but you got less work to do in this side over here. That's actually when you understand the logic. So you know that the worst case for the two worst cases cannot occur simultaneously. But when we actually do the big O analysis, we don't have to worry about the logic of the code. We only look at the structure of the code and work out line by line.
Yeah, I got that for this code, but
you're wondering about nested, right? Maybe that's what you were asking.
In a hypothetical maybe scenario, not exactly in this code. Like if we had like nested loop where and the first one the worst case would be like n approaching infinity, and then the second one would be n approaching 0.
So yeah, Ferris, let me talk a little bit. Okay, so I might know what you want to ask, but let me take a look. Okay, bear with me. I'm gonna get some clean version of that so we can talk about it. Just bear with me about 30 seconds. I'll find that page and then we'll talk about it. Let me see. Oh, one moment. Sorry. Okay, it should be around over here. Okay, that's good. All right. Let me paste it and then I'll switch to my iPad. Let me just get a clean page over here. Okay, a clean page over here. And okay, let's take a look. Okay, so we are talking about these for loop over here. At the moment, they are independent of each other. Okay, so let's say hypothetically, I believe that's what Ferris was trying to ask. Let's say we try to combine them together and kind of nest them. Let's say. So if we say for integer j equals 0, j less than or equal to I minus 1, j plus plus. Let's say that's an outer loop somehow. It's a brand new example, guys, so it's not really to do insertion. So I think we're just interested in the code structure. And then we say integer. You know what? How about this? So apparently you cannot really redeclare the same variable if you got nested loop, right? So I can change that maybe slightly. Okay, so you can, I think that will still actually satisfy your original question. So let's say k, let me just change that to k equals, let's say I plus 1. And then k less than or equal to n, and then k plus plus. Right? If you simply try to redeclare j again over here, that's not even valid, right, in Java, so we cannot do that. So Ferret, that's kind of what you're asking, right? If they are nested, what's going to happen?
Yeah, and then we have opposite worst case scenario for each of them.
Yeah, so I think in this case, of course, you will still need to look at a loop pattern, I think. So if you do that very quickly, so j is going to be from, let's say we'll do approximation. Now we are not interested in counting precisely, okay? So j will be from 0, 1, all the way to I minus 1, right? 0 all the way to I minus 1. Okay. So that's for j. And then also we got, let's say for k, when j is equal to 0, k is going to be from I plus 1, I plus 2, all the way to n. And also this one is always fixed. It does not really depend on j. You can see, right? So the value of k here only depends on I and also n. It does not depend on j. So it doesn't matter what j value is. You'll always be having this range over here. So it's going to be from I plus 1, I plus 2, all the way to n. And this one also I plus 1, I plus 2, all the way to n. So Ferrets, so far okay?
Yeah.
Okay, so let's now do that. This one is not too bad. Because over here, what is that? If you only think about this row over here, from I plus 1 all the way to n, it would be n minus I plus 1, and then plus 1, right? That's our little formula to calculate how many integers are there in the interval. This will be n minus I minus 1 plus 1. So this is what it is, n minus I. All right? And how many times do we need to do this? It will be from 0 all the way to I minus 1. So that will be n minus I multiplied by just I. All right? And then if we do that, it's going to be n times I minus I squared. Barrett, so far so good?
Yeah.
Okay. This one, interestingly, turns out to be not quadratic, because you can think about the I here is just an integer. Right? It's like a constant. The constant square is still a constant. But the n here is what can vary in the input size. So when I drop the lower term, this can be dropped. This is still constant. This is still just a constant, so it can be dropped. And then we can drop the multiplicative constant as well. So this one will be bigger of n, just for this loop structure over here that we're talking about.
Okay, thank you.
Paris, that's a very excellent question. So this also confirms what I said in the class. Whenever you see some nested loop structure, it's not necessarily quadratic, not necessarily. You can see in this case, it turns out to be linear. And sometimes it can just turn out to be constant. So the best way to find out is to see exactly how the loop pattern will look like for all the loop counters involved. And then from there, you get to count how many iterations, how many times, etc. That's how you can do the addition. All right. All right, guys, I can take one more if you guys want. Otherwise, I'll let you go. I'm willing to stay for one more question. if you need it.
I have one question, but it's on my
Yeah.
iPad. Is it okay if I share my screen?
Yes, you can share your screen if you want to. Yes, I'll let you share. Give me a moment. Let me stop sharing. Yeah, go ahead.
Sorry, I had to unmute.
That's okay.
Um,
Take your time. That's fine.
Yeah, so I found this question online. I guess my
Sure.
question is that how do we get to log n for like
This one
this
here, right? Okay.
for loop that's highlighted? Yeah.
Okay. Okay. Give me a moment. I'll take a screenshot and then I'll see what I can do. Okay. Let me just get that part. Yeah, one moment. Yeah. Just stay there. Okay. Yeah, you cannot stop sharing. I already got it.
Okay.
Thank you. Yeah, let me get prepared and then there we go. Okay. Okay, let me take a look. So we got some value for, okay, n should be the input size, I presume. So I will be, okay, this, and then, okay, we got triple nested loop, basically, right? So we got I here, we got J here, and also we got K over here, right? Let's try.
Professor, I just want to ask, like, are you sharing your screen right now?
Oh, sorry. I beg your pardon. I forgot to
Yeah.
reshare again. Guys, sorry. Let me do it again.
It's okay.
Okay, thanks for reminding me. Absolutely. All right, there we go. All right, let me say it again. So that's the example your classmate shared over here. So you can see it's a triple nested loop. Does it really have to be like a cubic? Not necessarily. Okay. I, J, and K. All right, let's take a look. So let's say when I value here, it would be n over 2, right? And then it's going to increment 1 all the way to n, right? So that'll be n over 2 plus 1, n over 2 plus 2, all the way to n. All right, that's the I. Let's see what's going to happen. So we got 3 dimensions. So we haven't really done this in class, but we can apply the same principle. Let me try to approximate a bit. So let's say the second dimension will be the j, right? So j is actually going to be 1, and then that's going to be okay, j plus. So the okay, j. It is kind of weird. Okay, I guess it's j plus plus. It's going to be incremented by 1 until certain value. 1, 2. So let me see. This part over here, right? Let's see. This part here is j plus n over 2 less than or equal to n. Let's try to rewrite it a bit. J less than or equal to n minus n over 2, which is n over 2. So it would be as if it's checking j is less than or equal to n over 2, right? So j less than or equal to n over 2. Okay, so let's try. And every time we just increment j. 1, 2, 3, all the way to n over 2. And it will be the same for every iteration, right? Because the value here only depends on n, not I, right? So that'd be 1, 2, 3, all the way to n over 2. 1, 2, 3, all the way to n over 2. This one also 1, 2, 3, all the way to n over 2. Right? So far we have done analysis for this part here. And what about this one here? All right. This one here, let's see. Okay. So this one here, I know your original question was about why it is log n, right? This one here is a very typical one where you can get log n. Let's get to see why. Okay. So now we are saying that for every value for j, we are actually going to evaluate certain iteration that's on k, right? So guys, for this example here, the valuable part is, so far we have done only 2 dimensions, but we got I and j. Well, let's say here, we got I and j. So that's why I here, the first dimension, j here, the second dimension, is kind of easy for us to see, not too bad. But now if you actually got 3 dimensions, you got another loop counter k. You follow the same principle. So now for every value for j, because every iteration for the second in the loop is going to incur the execution of the third nested loop. That's the principle, right? So now we want to work out what this is. What about the k value, right? So here, k will be from 1 all the way to n. However, we don't really have k plus plus, right? We don't really have that. We can have k is it's assigned to it's kind of a multiply by itself. And why is this log n? Very easy to see. Okay, let me give you one example. Assume n is equal to 1000, let's say. So what will be the k value? K will be from 1, and then the next iteration, k will be 2 times itself, 2, and then 2 times itself, 4, and then 8, and etc. Hopefully you agree so far. And if you analyze them more closely, this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. All right, all the way to, what's the closest one? That is smaller than 1000. For example, 9, right? Oh, sorry. I meant to say 512, which is 2 to the power of 9. Right, guys? Hopefully you're feeling comfortable, right? It's just a basic math over here. And then, how many do we have over here? So if you try to look at this one here, how many values do we have? Okay, here. So from 0 all the way to 9, which is 10. Right? This is basically, if you think about for this particular example, is basically log base 2, 1000, which is going to be 9 point something, but you just take this ceiling. So that's why it's log n. Are you okay with this?
Oh, my question actually was for the middle, because the actual big O for the whole thing was O n log squared n. So I was
Okay,
curious
first of all, are you
why.
okay with this?
Oh yeah, I was like, I'm okay with this because 10, if you change that to like a arbitrary variable, you can think of it as like it's increasing exponentially, so the inverse would be increasing
Log n, yes.
logarithmic.
Yeah, you can think that way too. Yeah, so I think at this part, if you understand, that's pretty good. I think that's a key thing. All right. So now what we got, so every time you got a single value for j, you're going to take log n time, right? Because count plus plus, this one here is actually just constant. Okay, this one here. Okay, so what about the final value? So this will be just 1. All right. So now think about, you want to count how many values do we have? How many values of I do we have? How many? Each one of them will take log n. That's the critical question. So how many times j changes its value? You can see when I is equal to this value over here. Oh, let's now calculate something here. You can think about this part over here. If we go from n over 2 all the way to n, it's roughly n over 2, right? And then each time, each value for I, we're going to take this many values for I, for every value of I, we're going to consider this many values for j. And how many values, for example, over here? 1 all the way to m over 2, which is n over 2, right? So this part over here is actually n over 2. All right, so now what will be the area for this rectangle, right? N over 2 times N over 2, right? Let's now calculate the big O. N over 2, about how many values we have for I, multiplied by how many values we have for j, for each value of I. N over 2, and for each value of j, is going to take this many k, which is log n. So that's why it will be big O of, we can drop the multiplicative constant here, so that'll be n squared log n. Is that the answer?
Oh, I thought it was n log squared n, but I might have read it wrong.
N log square? No, there's no log square.
Yeah.
Either you say
yeah.
your
I
n
just
squared
read it
log
wrong,
n.
yeah.
I think that's what you meant. Yeah.
Yeah, that's why I was so confused on how.
No, cannot be n. There's no log squared. All right. Yeah. But anyway, I think it's just for the benefit of your classmate. I think there's a nice example to actually take a look. Yes, for sure. Thank you. Good. All right, guys. Any follow up on this? Everybody's okay? All right, I think today we cover, I think it's nice. We actually cover again, we basically review about how you can do asymptotic analysis over here. And also we talk about how you can calculate precisely. I think all are important for your written test 1. All right. Let me see.
Professor, will you be posting this?
Yes, I'm going to post this. But gotta bear with me. I need to have some supper and then I'll try to post it. If you don't hear back from me, hopefully I'll try to do it tonight. If no, I'll definitely try to do that sometime tomorrow. I'll try. Okay. All right. So guys, do you have any final question? If that's short, otherwise I'll let you go. Anybody else?
I have a question that I'd like to ask you privately, if that's
Privately,
okay.
sure, no problem. So yep, I'll just wait. Anyone else who have question? All right, if no, guys, good luck to your test on Monday. Show up in time and then make sure you don't come to the right place. Don't come to the wrong place, right? Look at your test guide. All right, I'll see you there. You guys take care. Have a good weekend. Bye-bye.